Well, let's talk about the architecture of a standard DSO next. As mentioned earlier, each standard DSO is made of 3 tables. The first table is activation queue table, and as the name implies, this is the table where data is stored at first upon loading into a DSO. So it's kind of like a queue. And for this table, a technical key is assigned by a BW to each record. And the key is made of 3 fields: the request SID, package ID, and record ID. Okay, so each data load is considered a request by BW. So BW will assign a request SID. Okay, S here stands for surrogate. So SID is a surrogate ID assigned by BW to identify each data load. And for each load or request, it may have several data packages. So each package is identified by an ID. And within each package, you then can have several records. So each record is identified by an ID as well. Okay. So for each record, the unique technical key is made of 3 fields. And then the second table is active data table. This table is used to store the data upon activation of the data load. Okay, as just mentioned, that when we load data into a DSO, it is loaded into the activation queue table first. Okay, but it's the data in the activation queue table cannot be used for the processing. Okay, it has to be loaded into an active data table, and that is done after the data load is activated. Okay, so first we need to load it, and then we need to activate the data load. And after activation, the active data table will then have data loaded, and each record there will be identified by a semantic or real-world key. Semantic or real-world key is the one that is used in the business to identify different data records. So for instance, if we are talking about sales records, then the semantic key will be the sales order ID. Or if you are talking about purchasing data, then the semantic key will be the purchasing order number. And finally, the third table is the change log table. And similarly to active data table, the changelog table will have data loaded upon activation of the data load as well. Okay, and the key for this table is also a technical key, and it is also made of 3 fields. The first field is request GUID. Okay, GU stands for globally unique ID. Okay, globally unique ID. And then package ID and record ID. As you may have noticed, that the technical key here is very similar to the one used in the activation queue table. Okay, in fact, the only difference is in the first field, where you have request SID in the activation queue table, and you have request GUID in the changelog table. Okay, and I will talk about the difference in more detail using an example later on. And speaking of which, this example is actually taken from the SAP library, from the SAP website. And again, to recap, we have 3 tables for each standard DSO. The activation queue table, the records there are identified by a technical key generated by a BW that is made of a request SID, package ID, and then record ID or record number. Okay, same thing. Similarly, the changelog table also has a technical key, but with 3 fields. The first field is different from the one that is used in the activation queue table. And finally, the active data table has a semantic or real-world key, such as the record number or the document number used in the business world. So again, the DSO, standard DSO will need to be activated so that data can be loaded from the activation queue table into the other 2 tables. Okay, so after we perform the activation, data is then loaded from activation queue table to the other 2 tables as illustrated in this diagram here. Okay, and not only that, data will be deleted from the activation queue table if the activation is successful. Okay, so after activation, the activation queue table will be empty. If everything goes well, there's no errors, then the queue table will be empty. As another example, again, this one taken from the SAP library to illustrate the activation process. Okay, so in the activation queue table, first of all, we have one record loaded. The first one loaded, identified by the key. You have REQU1. That's a request 1, and then package 1, P1, record 1. Okay, so that's the technical key there. Followed by the real-world key 4711. That's the document number, for instance. It may be a sales order number or a purchasing order number, and so on. Okay, so we have just loaded one record into the activation queue table with a $10 amount. Okay, so upon activation, the first record there is then a copy from the activation queue table into the other 2 tables. So now you see in the active data table we have one record 4711. That is the document number, and then amount is $10. Okay, and similarly, you have the same record recorded in the changelog table, but with a technical key, request ID, package ID, and then record number. Okay, and that request ID is different from the request ID in the activation queue table. Okay, the reason is that, as I mentioned earlier, that if the activation is successful, then data will be deleted from the activation queue table. Okay, so next time when we load another record into the activation queue table, SAP will generate another request ID, which may or may not have been used before. Okay, it's unknown. Therefore, to make sure that every record in the changelog table is unique, the request ID is known as globally unique ID. So that ID is different from the request ID that is generated for each record that is coming in to the DSO. All right, so that's the only difference between the ID between the changelog table and the activation queue table. All right, so far we have just covered the first record, basically the one with a $10 amount. Okay. And then after a while, we may have another record coming into the DSO. So now you see a second record there, REQU2, P1, record 1, and then record number, and the amount is $30. Just so happens in this example that upon activation the second time, okay, SAP will look at the two records that have been loaded so far, and notice that the two records are actually identical. Okay, I mean they are the same thing basically, because the document number is the same. Okay, 4711 pertaining to a particular sales order number. It's just that originally it was recorded with a $10 amount, which somehow was error. I mean the correct amount should have been $30 instead. Okay, so that's why they loaded the second record to replace the first one. All right, so as a result, in the active data table, the first record is overwritten. If the record is identical, the first one should be erased and overwritten by the second one, because the sales amount should have been $30 as opposed to $10. Okay. But notice that in the changelog table, we do not overwrite the old record. Okay, instead, BW will record the same record second time with a negative dollar, with a negative sign. Okay, so instead of $10, the second record is inserted as a negative $10. All right, and then BW will insert the third record there, which shows the actual amount of $30. Okay. Now you may be wondering why the trouble? Okay, why don't we just simply overwrite the old record in the changelog table as well? Okay. But basically, as the name implies, the changelog table keeps track of all the changes that we made in the system. Okay, so we need to make sure that every change is documented, so that if necessary, we can go back and audit the results, or if necessary, you may need to roll back the changes and so on. Okay, so we need to keep track of what was recorded before and also what is recorded currently. Okay, so in the changelog table, the second record there actually is known as the before image, using the terminology of database. Okay, so the before image is basically the same image as the original image with a negative sign to offset the amount. Okay, and then the third record is known as the after image, which basically shows the correct amount in the system, which is $30 for this particular sales order. All right, and finally, even though it is not shown here, that remember that a DSO can be used to load data further into other objects, such as info cubes in the BW system. Okay, and when we talk about info queues in another chapter, you will notice that in an info queue, it's kind of like a data warehouse. Okay, data is not overwritten. Instead, data is accumulated. Okay, so in other words, we will not send the $30 amount to the info cube as the new sales amount. Okay, instead, the before and after image will be combined, so that the net result is $20. That amount will be sent over to the info cube, so that we have a record of $10 before, and then now we have another record with a $20 amount. So in the info queue, you will show that for this particular sales order 4711, the correct amount is $30. Okay, which is the total of $10 and $20 that will be generated from this particular DSO. Okay.